Great all. Today our topic is machine vision for measurement. In robotics, machine vision are utilized for identify the objects and also identify the persons, those who are crossing their limits. So this machine vision concepts can be used for measurement in industries. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Here, how we utilize machine vision concepts in industries means for measure the product means the geometrical nature of the product with the aid of ccd camera and image processing techniques. The image processing technique generally carries image capturing, image acquisition, denoising with the filters, comparison of real image and actual image, mapping of image, image processing algorithm. These are all the things the machine vision process is followed for measuring the components. Similar procedure is utilized in industries. Then machine vision is used for identifying tool wear, tool condition monitoring, surface finish, discontinuous perimeter, broken inserts on the machine spindle tools, and automated visual inspection than normal manual visual inspection with a naked eye. The cameras are utilized for making images, and we can infer what all the difficulties, flaws available on the surfaces, and the chatter detection. From this machine vision, we can also interpret the data about machinery chatting. Chatter means the vibration details of machinery also we can measure, and the size measurement, size of the whole, size of the component. Likewise, we can get the geometrical data from machine vision system. How? Let's see. Some camera for machine vision system to image acquisition and image capturing. On behalf of previous researchers, they are utilizing different cameras for capturing the images with respect to industrial products. Likewise, Dahang THHP3 103 UC. It has 2048 into 1536 pixels. This camera is utilized for measuring the tool wear, and also JHS MS 500 BF E 1 divided by 2.5 inch CMOS camera for measuring the size with the pixels value of 2592 into 1944 pixels. So that pixel accuracy is important for different measuring techniques. Not only tool wear and size measurement, from the camera we can measure the surface roughness also. These are all the five different cameras that are utilized for the researchers for identifying the flaws on the surfaces and the tools of the industries. And then what are all the steps available with the image processing means the first step is image capturing. What is image capturing? The basic machine vision system starts with the image capturing with the CCD camera after light emitting from the source. Now, normal our flashlight, based on the flashlight brightness, we can capture the images of humans. Likewise, we may utilize the concept for capturing the picture in industrial product also. The illuminated image is converted into digital image by the use of image sensors. From the sensor, we can convert the image data into 0 and 1. 1 means brighter and 0 means darker image. Likewise, we can convert the normal image into digital image. Then step 2, image acquisition. Image acquisition is the process of converting optical image to digital image. This conversion process follows three different steps such as image sensing, representation of image data, and digitization. And then after data acquisition, the step moved to third, that is image processing. Image processing is important, which is one of the pre-processors is to prepare the pixel values and it convert it into suitable form for further processing. It involves five different operators like point operation, global operation, neighborhood operation, geometric operation, temporal operation. Likewise, it splits the image available with the memory of computers. From this, we can process the image with the 0 and 1. And then step 4. Not only the important with the image capturing, image acquisition, likewise, we may go for feature extraction. feature extraction means we already store the image, the good image with the memory storage. From that, we compare the captured image with that stored image. From that, we can get the real data about the captured image and real product available in front of camera. So that feature extraction means identification of inherent characteristics of the object or image. Then after feature extracting the image, we go move through pattern classification. Here, what is pattern classification? What are all the things wanted and related with the real product? What are all the unwanted things available with the images? Likewise, we can classify, which is known as pattern classification. So pattern classification is the final step of machine vision. In this process, the identification of unknown object from known group of the objects, this which is the basic procedure available with the machine vision system. The machine vision system is always started from CCD camera. Based on the CCD camera captured image, that image is transferred to image processing software. Image processing software follows image processing algorithm. After that, it moves to backlighting technique. From that, we can remove the unwanted light sources from the images. After that, interfacing computer and camera, and then image capturing. After that, image sensors for generating optical image. Then image acquisition. Image acquisition follows three steps. So first one is image sensing, representation of image data, and then digitization. Here the 0 to 1 conversion is happening. After that, image processing. Prepare the pixel values and convert it into suitable form for further processing. And then it moves to image processing operations. What are all the operations available with the image processing means point operation, global operation, neighborhood operation, geometric operation, temporal operation. These are all the operations available with the image processing technique. After completing this technique, the image moves to feature extraction. Feature extraction is generally utilized for identification of inherent characteristics. Finally, pattern classification. Already I told you what is meant by pattern classification, which means we can remove the unwanted images from wanted images. And then one of the examples I want to discuss with you, that is how do we convert the tool wear measurement in manufacturing industries and the machine shop. The tool wear measurement always started from image capturing of initial tool, so which means unknown tool images. The image captured from unknown tool image. After that, calculate the cutting tool tip area from the original image. After that, we can perform the same tool with the machining operation, perform the cutting operation. After that, capture the image. After performing the cutting operation, we again take the image with the performed cutting tool. After that, we can subtract the unknown and own tool areas, so that first I capture real image of the original tool. After that, I moved that it into cutting operation. After that, after one of the tool, I again capture the image. I compare the original image and the worn out image. From that, I can subtract what are all the unwanted images, what are all the unbound images with the real image. I subtract both the thing, both the thing. From that, I can identify the own area. Likewise, I can measure tool wear rate. I mean tool wear of the cutting tool. After that, surface finish, which is the tool wear is related with the machine tool factors. Okay, now I consider product quality, so that surface finish measurement also important in manufacturing industry. So that how can we conduct a surface finish measurement? The surface finish measurement is followed following three steps. The steps are image capturing, filtering the image, finally surface roughness measurement. First, already you know about image capturing throughout the machine vision camera, that which is CCD camera. Filtering the image. Already in tool where so measurement, I told you how do we subtract the thing from real image to captured image. Real image means already you store the data from the original product it into memory. After that, you may take one out tool from the camera. From that, you can compare the real image and the laterally captured image. From this, we can subtract both the things. Finally, may get the original data. Likewise, this operation is known as filtering the image. Finally, from there, we can measure the surface roughness. But surface finish has its own role for identifying the surface roughness values, which may RA or RMS. Likewise, we can measure with the surface finish measurement through machine vision system. Here, surface roughness measurement. How do we conduct the surface roughness measurement with the machine vision system means it follows the measurement algorithm. The measurement algorithm always concentrated or considered about white area intensity is denoted by 1. Black area intensity is denoted by 0. How we digitize the image? Likewise, we conduct the algorithm, surface finish measurement algorithm. The white area is represented by 1. The black area is represented by 0. After that, how do we measure the surface finish? How do I work with the surface roughness measurement algorithm? Let me see. The surface roughness measurement is based on change of intensity value from 1 to 0, which means brightness to dark. That is 1 to 0. The algorithm for measuring the surface profile as follows. The first step, the algorithm initiated by scanning the first pixel of the first column in the image matrix, which is every image we can split up into M cross N matrix. From that, M cross N means M is horizontal, N is vertical means we can allocate the different N rows with the M column. Okay, so that first N column I consider first N column I scan with the pixel image matrix. Okay, the algorithm initiated by scanning the first pixel of the first column in the image matrix. If 0 obtains, stop the scan and follow the second row. 0 means the dark side, so that surface is not available with the image, so that we move to second line of the image. So if it is not 0, scan the second pixel in the same row. Likewise, I conduct the third step. After that, fourth step is the scanning procedure continues to find a 0 pixel in the first row, so that I move my scanning object from first row. In first row, every 0 I can check. Okay, from that, if I get 1 means there is a surface available. If I get 0 means there is no surface, so that I move my scan procedure for the first row. After completing the first row, I move the second row. I follow the same procedure for all the rows. From that, if I get the 1 means there is a brightness available, so the uh, surface is available with the image. Okay, likewise I may get the solution. If 1 means I fix through the feature extraction concept, if I got 1 means there is the surface finish of 1 micrometer. Likewise, I may fix the feature extracted value. From that, I can compare this scanned image to that. From that, I may get so surface roughness 1 micrometer. Likewise, I got 1 and 0. Finally, we can get the surface profile from this measurement algorithm by the conversion of pixel roughness value to micrometer. From this procedure, we can measure the surface roughness of the equipment. And then future requirements. Not only tool wear surface finish, it can be extended to their own limits, because nowadays industries are converted it into smart industries, and also the industries are moved to industry 4, so that this machine vision can be utilized and incorporate the digital data into common memory storage devices, so that the smart machine vision system can be developed through add intelligence in previously available automated machine vision system. From that, we can improve the reliability, safety, and the quality of the product. From that, we can ensure the product quality in performance also, so that we can reduce the maintenance activity during the operating conditions of the machine. Thank you all.